Hello, this is Bukanya Saraj, and from our previous discussions, we talked about the atomic structure. In the atomic structure, we saw that almost everything we have in our life is made up of tiny particles called atoms with subatomic structures like protons, neutrons, and electrons. Today, I want to look at the periodic table. By the end of our discussion, we shall be able to look at the periodic table and see how the scientist called Dmitry Mendeleev came up with the arrangement of elements in the order of their atomic numbers, from the lightest hydrogen to the heaviest, which is uranium. So, of course, after this lesson, we shall be able to understand the periodic table and sort the elements very well. Understand how the elements are placed in the periodic table due to their similar properties. Identify the periods, groups of the particular of the elements in the periodic table. And then look at the elements which are metals, non-metals, metalloids, and the one we are calling the inert gases or gases. In this discussion, you need to have at least the periodic tables, which I think will help you to understand them very well. And then we shall use some lighters so that we can highlight some of the elements we're talking about as we shall proceed. As I've said that in 1869, a gentleman called Dmitry Mendeleev created this periodic table. So he's really credited to be the father of the modern periodic table, arranging elements in the order of their atomic numbers. Use Z to represent that, and then the properties. One thing that you have to remember here is that an element is a substance made up of only one kind or type of atom. Remember, I said that there are about 92 types of atoms, and that means that even the elements will be 92. Though there are some that have been discovered now to make the list go up to 118. So the list showing the lightest element, iodine, to the heaviest element, uranium, is now referred to as the periodic table. Remember, each element is represented in a shorthand of 1 or 2 letters called a symbol of the element. If you try to actually define, I shall say, the periodic table is the arrangement of elements in order of their increasing atomic masses. It is made up of rows and the columns. The horizontal rows are called the periods, and they are assigned numbers according to the electron shells or energy levels. Remember that time to have the energy levels or the shells. So those shells that you have around the nucleus will really be representing the periods that you're going to see in the periodic table. And then we shall label them using our numbers 1, 2, 3. And then the vertical columns are referred as the groups. So the groups should be written in Roman numerals. So the electrons in the last shell will help us to know the period, I mean the group of a particular element. So if you try to look at the periodic table, we're saying that we shall label, moving downwards, we shall be having 1, 2, 3, 4, 5, 6, 7, which means that you're talking about 7 periods. So each one is hydrogen to be in period 1, lithium, period 2, which means the shells are 2. Sodium, period 3, which means the shells are 3. Like that, like that. And then here, as you move this side, you can talk about group 1, group 2, group 3, group 4. There's a reason I'm skipping those in the middle, as we shall see later on. Then group 8 or group O, which means that the last shell is filled up. So you can call it group O or group 0. So as you move down, we're talking about periods. And then as you move across, we're talking about the groups, as you have seen there. So one thing you have to remember that the groups are like a family. The members in a particular group resemble chemically and also are given a particular name, like a family name. See? So you can talk about group 1 as alkali metals, except hydrogen. It may not be a metal because hydrogen is special, as we shall see later on. So the group 1 elements have 1 electron in the last shell, and they tend to have properties like being malleable. That means when you hit them with a hammer, you can shape them up without cracking, as you have seen some of the metals. They're soft, they explode with water, and they conduct electricity. If you connect them to a circuit, the bulb will light up. They also conduct heat. They are shiny, solids, and ductile. So we shall look at a diagram trying to illustrate some of that, as we are going to see. Then group 2, they are alkali earth metals. They are also solids at room temperature, RTP. They conduct electricity, shiny. They are also malleable, so not brittle, which means that when you hammer them, they don't break. So in other words, group 1, group 2, and group 3 are all metals because they are found on the left of the periodic table, and they react by losing electrons to attain a stable state. So because they have 1, 2, 3 electrons, those electrons are not stable. They can easily lose them, and they have those properties of, especially the ones that we find that the members that are metals. I can give you a diagram showing those that are metals. We find that most of these ones are going to be like iron, aluminium, steel, zinc, copper, brass. Then you can also talk about titanium, tin, lead. All those ones are known to be metals. Then we have the semi-metals or the metalloids. They are in between, that is carbon and silicon. They are group 4. So the group 4, they are going to be found to be the semiconductors. The group 4 are semiconductors because they're just in between. So if you try to put them on if you try to put a bulb, the bulb is a little bit dim. It's not having a big light for those kind of metals. I mean the metalloids or the semi-metals. Also they can be solids, and they tend also to be brittle. You can hit them and just turn into crystals. Then we have the nanometals. Nanometals are mainly group 5, 6, and 7. And these ones tend to react by gaining electrons. They're opposite in properties to the metals. Liquids, gases, and some pure solids. They're insulators. They don't conduct electricity. That means you find also they can also be a little bit brittle, as you saw. Then group 7 are mostly known to be halogens. Then the group 8 are the ones who said they're inert, they're noble gases. So the non-metals, you can see the carbon, which we say that is in between, you find they tend to behave like that. Sulfur, phosphorus, carbon. So those are some diagrams showing those ones. You can also combine metals and non-metals and see the way they appear. So we have talked about group 8 or group 0 being the noble gases or the inert gases. They don't react. They're non-reactive. And then finally, I can give you the ones that we see that we're in between. They are called transitional elements. These are in between group 2 and group 3, as you saw in the periodic table. Towards the bottom, they form the colored compounds. These elements have variable valences, as we shall talk about the valence in future, as we shall see in our coming lessons or videos. The examples are copper. It's going to be colored iron, chromium, cobalt, and so on. And then finally, I'll give you a small idea about the trend, the activity of elements. Down the group, for the metals, they will increase in the activity due to the increase in atomic size. The outermost electrons become loosely held, but for the non-metals, the activity decreases. Adjacent on that, we shall go into that in detail. Now, of course, the periods, elements from the left to the right, the activity decreases from group 1 to group 4 and increases from group 7 and falls in group 8. Due to that effective force of the nucleus increasing, and then the outermost electrons become more strongly attracted. So we shall add on in other lessons. Don't forget to subscribe to this channel and get more ideas about chemistry and more ideas also in mathematics as we shall.